Hello students, again welcome to my YouTube channel Maths Insights to discuss important topic. In this video, I am going to discuss the algebra of matrices. Algebra of matrices means nothing but addition, subtraction and multiplication of matrices. In this limited time, I want to discuss how to add two matrices and how to subtract two matrices and what are the properties of the addition of matrices. I am asking a simple question to you, whether can you add any matrices? No, you cannot add any two given matrices. Suppose if I am taking A is equals to 1, 2, 3, 4 and P is equals to 1, 2. You cannot add these two matrices. Why? Because the orders of these two matrices are not equal. Therefore, you cannot add any two given matrices until and unless they will follow the condition for addition of matrices. What is that condition? If you want to add any two matrices, the matrices should be of the same order. Then only it is possible to add or subtract the matrices. I am taking one example. If you take this example, you cannot add because the order of this matrix is 2 by 2. The order of this matrix is 2 by 1. These two are different matrices of different orders. So what I said, if you take two matrices of the same order, let this matrix be 0, 4, then this will also become a matrix of order 2 by 2. These two are of the same order. Then how can I add these two? So A plus B is equals to 1, 2, 3, 4 plus 1, 0, 2, 4. So I came to know that these two matrices are conformable for addition. Why? Because they are of the same order. Now question is how to add them. You have to add the corresponding elements of these two given two matrices. What is meant by corresponding element again? The corresponding element for this one is here these two. That means wherever the position of this element is, that means this element is in the first row, first column. Similarly, whatever the element in this matrix, first row, first column, that is called its corresponding elements. You have to add the corresponding elements. So for 1, the corresponding element is 1. For 2, this is 0. For 3, the corresponding element is 2. For 4, the corresponding element is 4. Therefore, an addition of these two, 1 plus 1 will become 2, 2 plus 0 is 2, 3 plus 2 is 5, 4 plus 4 is 8. So you got A plus B. Similarly, if you want to subtract any matrix from any particular matrix, definitely the orders of the two matrices must be same, like addition of matrices. By taking these two matrices, I will do the subtraction also. Subtraction and addition are nearly same, only the difference is addition of corresponding elements here and subtraction of corresponding elements here. So when I want to do A minus B, 1, 2, 3, 4, you have to write the first matrix and then the second matrix 1, 0, 2, 4. So you have to present the matter as you know. If your presentation is not good, definitely you will get less marks even though the answer is on the paper. See, this is 1 minus 1, 2 minus 0, 3 minus 2, 4 minus 4. Just I am subtracting the corresponding elements. So 1 minus 1 is 0, 2 minus 0 is 2, 3 minus 2 is 1 and 4 minus 4 is 0. So in this way you can subtract any two matrices and you can add any two matrices if they are of the same order. Now I will represent the addition and subtraction of two or more matrices. You can add whatever the number of matrices you can add if they are of the same order. I will represent in the compact form. Suppose if you take a matrix A whose elements are Aij and order is m by n, and taking another matrix called B whose elements are Bij, it should be of the same order. Why? Because as we discussed, A and B are conformable for addition only if they are of the same order. So I am doing A plus B, that is equals to Aij plus Bij whose order is also m by n. When you add two matrices of orders m by n and m by n, the resulting matrix will also be of the order m by n. Similarly, if you want to subtract two matrices in the compact form, I am representing Aij whose order is m by n. Okay. So if you write it minus Bij, and the resulting matrix should also have the same order. See, this will happen for all I comma j. Now we will discuss what are the properties to be followed by the matrix addition and subtraction. Addition and subtraction are nearly very same as we discussed. These are the properties of addition of matrices. The first one is commutative property. What is commutative property? If you take A and B which are conformable for addition, means if they have the same order, and if A plus B is equals to B plus A, then we will say that matrix addition follows commutative property. Yes, it is true. Therefore, we will say that A plus B is equals to B plus A. Right? If A and B are conformable for addition. Next, second one is associative property. Associative property means if you take any three matrices, let them A, B and C, which are of the same order, then if you do A plus B first, then adding C to that, you will get a result. That result should be same if B plus C is to be first added, then to that A is added. You have to get the same results on both sides. Coming to the third one, existence of identity element. Before going into to discuss it, you have to remember the identity element in the algebra of numbers. Identity element in algebra of numbers is under addition, it's 0. Suppose I am taking a number 2 and adding 0 to it, or 0 is added to 2, you are getting 2 again. Then this 0 is called identity element under addition. Similarly, in matrices also, there exists a matrix which I am adding to a matrix, let A, that is null matrix, or null matrix is added to A, you are getting back A again. Then this null matrix O is called the identity element under addition of matrices. Therefore, in matrices also, like algebra, the identity element under addition is exist, and it is null matrix whose all elements are 0. For the fourth one, existence of additive inverse. Again, you have to go back to algebra. There is additive inverse under addition. Suppose 2 is added to a number, or a number is added to 2, you have to get back additive identity element, that is 0 in algebra. What is that number? Very clear, it is minus 2. That means if you put minus to the original number, then that is said to be the additive inverse. Clearly here also, if I take a matrix A and another matrix is added, or another matrix A is added to A, if you have to get back null matrix, it's clear that minus A is added to A to get null matrix O. See, minus A is called additive inverse under addition. Very simple. Minus A means if you change all the signs of elements of A, then you will get minus A. Very simple. Then if you add A and minus A, since they are of opposite signs, you will get every element 0 in the resultant matrix, which is called null matrix. So additive inverse exists, identity element also exists in addition of matrices. Final one is cancellation loss. Under addition of matrices, cancellation loss holds good. Suppose if a plus b is equals to a plus c, on both sides, that is on the left side of a plus b and a plus c, you have common matrix A. If you remove them, don't cancel it, actually you have to do the operation. So b is equals to c, you will get b is equals to c. That means you are cancelling a which is on the left side, that's why it is called left cancellation law. Similarly, if b plus a is equals to c plus a is common on right hand side, and if you remove that, then you will get b is equals to c here also. Then this matrix addition holds good for cancellation loss also. Coming to the subtraction, since a plus b is equals to b plus a, but a minus b is not equals to b minus a, that means subtraction of matrices will not follow the commutative property under subtraction. Similarly, associative property also will not holds good for subtraction of matrices also. I hope this video is helpful. If you think like that, don't forget to share it, subscribe it, and encourage me to do more videos. We will meet in the next coming video. Until then, have a nice day. Thank you very much.